Let us go step by step, cabbages. I'll wait for a moment for everybody to complete the obvious first step. What is it? Changing it to make it simpler, right? What's the only letter that would be a stupid letter to use here? X. You can use any other of the other 25 letters in the alphabet, or you can go crazy and use a symbol or a Greek letter. I don't care, as long as you don't use X. I'm going to use Q, because Q doesn't get a lot of play. Q squared plus 8Q plus 15. Can you factor that? Wait, I lie. Does everybody understand what I just did?
Yes.
This trinomial up here says you have some base squared. Please notice I still have a base squared, right? Then it's 8 times that same base. Please notice I have 8 times that same base. Everyone is good, right?
Yes.
Now, factor that. What do you need? You need numbers that multiply to 15 and add to 8. Is it 1 and 15? Is it 3 and 5?
Yeah.
Yes. So it is Q plus 3 and Q plus 5. Correct? Is there a Q anywhere in the original equation? So can I have a Q anywhere in my answer? No, because Q doesn't exist in the original equation. What is Q? X squared plus 4x plus 3, right? And what's this one?
X squared plus 4x plus 5.
Now, are there any like terms to add up? No. Any like terms to add up there? No. Okay. Does this look like something I can do some math with? What does it look like? Does it not look very similar to this expression? Squared, coefficient, variable, number? Doesn't it? So isn't it possible that one of these two might factor like that? We should check, shouldn't we? Are there numbers that multiply to 3 and add to 4? What are they? 1 and 3. So this guy works. He's x plus 3 and x plus 1. Everyone agree? Okay. What about this guy? Are there numbers that multiply to 5 and add to 4? What are they? Can't be negative. These are both positive. 5 and 1 will never make 4, right? If we're not allowed negatives. Huh? 4 and 1 doesn't multiply together to make 5. So does this guy factor? If he doesn't factor, what do we do with him? He stays the same. We leave him alone. X squared plus 4x plus 5. Again, did any of that touch on anything that you didn't already know how to do? Did it? So all we got to do is try stuff, right? Now, sometimes kids don't believe me. And I have to spend an hour and a half expanding this, collecting like terms, and then factoring that. And then they're like, oh. You're welcome to not believe me. You're welcome to expand this, collect all your like terms, and then factor it. Go to town. Or you can trust me, because this makes perfect sense when you think about it, doesn't it? What are we going to do over here in green? There's one very slight difference. What's the very slight difference? There's a y. Right? But we know how to deal with that. Instead of q plus 3, it'll be q plus 3y, won't it? So we're not, the y we don't even have to care about. Do we notice anything else in green that will help us? That and that are the same. So what can I make them? Any other letter to make it look easy, right? Choose your letter. B, sure. So this is now 3b squared plus 12by minus 36y squared. Now, just like on the old TV show House, you may not know what you're doing, but you know something about that doesn't look right. What about that new line in green is something that bothers you, something that you don't like? Please notice we've done 3 of the... Oh, Bailey. You don't like that 3 at the beginning because we've only dealt with a letter at the beginning. How do I get rid of times 3?
Divide it by 3.
I can divide it by 3. Now, if I'm lucky, it's going to work all the way through. Does it?
Yeah.
So we do that. 3, and I get b squared plus 6b, liar, 4by minus 12y squared. Yes? Is there anybody that doesn't know what I did there? I divided out of 3. Greatest common factors. First kind of factoring we did. Now, does this look like something we can deal with? Looks a lot like this, doesn't it? Which means I need numbers that multiply to what? 12 and add to what? Negative 12 and add to what? 4. Is it 1 and 12? I know, Louis. Is it 1 and 12?
No.
Is it 2 and 6? Yes. How will 2 and 6 get me positive 4? Minus 2. So this is b minus 2. Y, because I need that y, don't I? And b plus 6y. Does everyone agree? Is anybody lost there? Okay. In the original question, is there a b? There is no b. So what must I do with these b's? I got to replace it with what?
The original.
Which is what?
2x plus 4.
So this is 3, 2x plus 4 minus 2y. Correct? What's the next one? He waited patiently. Excellent. Well done. Now, what do you notice there, and there? They are all factorable, aren't they? What can come out of the first one? 2, all the way across, correct? Where does the greatest common factor go? To the front. So what's coming out here? 2. And what's going here? The answers. What's 2x divided by 2? X. What's 4 divided by 2? 2. What's negative 2y divided by 2? Negative y. Correct? What about here? What's coming out here? 2. So what's coming to the front? Another 2. What's 2x divided by 2? What's 4 divided by 2? 2. What's 6y divided by 2? 3y. I had a 3 out front and a 2 and a 2. What do they all become now? 12. 2 times 2 is? 4 times 3 is? 12. And now that one's done. It's a lot of use of the things you already know. But each thing is something you are all able to do. Understand? All right. Shake your sillies out. Take a moment. Go fill up your water bag.
Yeah, water bag.
And when you're back, we're going to do the third type of factoring. You have about a minute and a half. If you're not leaving, turn to page 133. Okay, ladies and gentlemen, please do me the mathematical service of actually writing this out in the long way that I originally taught you to expand binomials. So that means you need to write 2 lines, right? You're going to do this one, which is going to get you x squared minus 4x, right? Then you're going to do this one, which is going to get you plus 4x minus 16. And then what are you going to do at the end? Add it all up. And you're actually going to write this out. Plus 0x minus 16. Now, does what I just wrote strike something in your memory? Have you seen that before? Yes, you've seen it in 2 ways. 1, you've seen trinomials in general, right? And 2, you've seen this specific trinomial, right? In math class, I left that 0 in there on purpose because I wanted you guys to recognize that you need numbers that multiply to negative 16 and add to 0. And you, of course, know that they are 4 and negative 4. And when we write that factor out, we get x plus 4, x minus 4. Now, how would I write this if it wasn't math class? That would be x squared minus 16. And you would say to yourself, self, wait a minute. X squared. 4, 4, 16. There's a relationship there that Mr. Myers has already talked about. And it was x squared and x. Those are square roots. 16 and 4. Those are square roots. If it happens once in math, how often does it happen? Always. So without even writing it down, every single one of you in 2 seconds without writing it down should be able to tell me all of these answers. What's the first one? Plus 7 minus 7. What's the second one? Plus 8 minus 8. What's the third one? Plus 6 minus 6. Right away, correct? Which means if you can do it this way with all these zeros written there, you must be able to do it that way. Right? What is the name of this third type of factoring of polynomials? Difference of squares. Hint, it's in the title spot. Difference of squares. What math is difference? Subtraction. If there's an S on the end of the word, what does that mean? There's more than one. Is that a perfect square? Yes, it is, because the square root of x squared is x. Is that a perfect square? Yes, because 16 has a square root of 4. Is that a difference? Yes, which means if this happens once, how often will it happen? Always. So what if I had this? A squared minus b squared. How would you factor that? You would square root both. So it would be a plus b, right? And then what? A minus b. And how do I get this a and b? I square root that and I square root that. Does everyone see how it works? Now I need you to notice something. It's called difference of squares, which means, will it work with, what did I just do there? I don't even know. Will it work with this? Son of a motherless goat. X squared plus 49. Will that work? Of course it won't. Why, Corey?
Because then you'd have to add the other one there because they'll cancel out to make 0.
You can't cancel out the middle. This would be x squared plus 0x plus 49, right? So I would need to multiply to 49 and add to 0. Can I do that? 7 and 7. 7 plus 7 doesn't give me 0, does it? So it has to be a difference of squares. Is everybody cool? Okay, that is problem 1 with this. Because it seems super easy, right? Square root, plus minus, done. Right? Okay. At the very bottom of this page, just down by the 133, draw a line, and I need to remind you of a few things. Again, it's something that you already know, but I need to remind you. What is the square root of x squared? X. Why? No, not because I said so. Why is the square root of x squared x? It's the opposite of the power thing. That's one way to remember it. Is there another way to remember it? What is x squared really? X times x. Isn't that a group of 2? So out would come a group of 2, correct? Would anything be left under there? No. So it's just x. Everybody with me? Okay. What would the square root of x to the 4th be? X squared. Why? Because there's 2 groups of 2 coming out. Everybody with me? Okay. What would the square root of x to the 6th be? X cubed. Are you seeing the pattern now? What would be the square root of x to the 8th? X to the 4th. Okay. Then what would be the square root of x to the 4th? Squared. And what would be the square root of x squared? X. What is happening to the exponents when I'm square rooting? They're dividing by 2, which means if the exponent is even, does it have a square root? Yes. So what would the square root of x to the 14th be? X to the 7th. Can I square root x to the 7th?
No.
Why?
Because the exponent's uneven.
Because the exponent's not even. Everybody with me? Everybody? All right. Knowing what you know now, let's have a look at this very first one. Because this very first one, I start you right away with tricky stuff. Because how easy is this? This is super easy, right? All of you were doing that in your head in 2 seconds, right? So I'm forgetting about it. I'm moving on. Everybody okay? All right. Let's look at the first way this can mess you up. Is that a perfect square? Yes or no? And how do you know?
Yes.
Why?
Because 16 is an even number.
Awesome. Is that subtraction?
Yeah.
So is it a difference?
Yeah.
Excellent. Is 1 a perfect square? Yes, why? Because 1 times 1 is 1. Square root of 1 is 1. Everybody agree? So is this a difference of squares? So I just follow the rules. I square root the first one. What is the square root of x to the 16th? X to the 8th. And then I add the square root of the second one. What's the square root of 1? 1. Everybody agree? What's the second part of the expression? X to the 8th minus 1. Am I done? No, I'm not. Why? Doesn't 8 have a square root? Isn't that subtraction? Doesn't 1 have a square root? So I go again. I can't forget about the original one. This is now x to the 4th plus 1 and X to the 4th minus 1. Am I done? Why not? Because I can go again. Can I forget about the first two? X squared plus 1 and x squared minus 1. Surely now I am done. No, why? Because I can do it one more time. X to the 8th plus 1. X to the 4th plus 1. X squared plus 1. X plus 1. And finally,
X minus 1.
surely now I am done. Who's Shirley? Joke never gets tired. One day I will have a student named Shirley, and it will ruin my words. Or it'll be awesome because Shirley will be like an A student, and I'll be saying, Shirley, I'm done. And she will say, yes, you are. Hopefully. Is everybody cool? Oh, yeah? Now what is she? Oh, okay. The way you said it. All right. Now, again, don't approach a math problem like it's something you've never seen. Because we are now 3 months into this course. Have I ever given you something that you have never seen? Have I ever given you something that you have not got the tools to do? You may have forgotten them, but you have the tools, don't you? So look at the second one, and let's think about it for a sec. If that wasn't there, what would you do? Check for square roots. Are those both squares? Yep. Is it subtraction? Yep. So you know what to do, correct? What would it be? What would this be? Without that y there, what would I write?
X plus 15.
And then?
X minus 15.
Right? Okay. But there is a y there. If there was no x there, what would I write? Y plus 15 and y minus 15. Done. That's it. Why is that it? Because x times x will get me my x squared. Y times y will get me my y squared. Plus 15xy minus 15xy falls out. 15 times 15, negative 225. The other thing is, let's say you forget all the rules, but you somehow get to an answer. Is it easy to check? You just multiply it out. If you get back to the original, you've done it right. Everybody good? All right. Let's look at 3. Is 3 going to work for us?
Yeah.
Why?
Because 8's even.
8 is even, and
144 is
144 is a perfect square. So how do I write the answer?
Z to the 4th plus 11.
11?
12.
And?
Why do you put a line in the middle of your Z?
So it doesn't look like a 2.
Z plus minus 1.
Am I done?
No.
Really? I can square root 12? Can I square root 12? So am I done? Yeah. 4. Tricky.
Why are you doing this to us, Myers?
If there was no 4 and no 25, could you do it? Sure you could. Why? They're both even. If there was no x and no y, could you do it? Why? They're both perfect squares. So, you must be able to do this, right? I take the square root of the first one. What's the square root of 4? 2. What's square root of x to the 6th?
X to the 3rd.
Absolutely right, Eric.
Oh, I did it right.
Plus, what's the square root of 25?
5.
What's the square root of y squared? Y. And then what do I write? Same thing except minus. People tell me this is difficult. Is it? All of you were doing this in your head right over here on this other page, weren't you? Now, you guys, you're intelligent young people. Would I really stop my notes with that much white space on the paper? No. Only if I was silly and didn't want you all to get A's. But I do want you to get A's. So we're going to write 2 more tricky ones here. Everybody ready? You liars. It's 1 step. Don't give me that horse pucky. What if I gave you this? 12x cubed minus 48x. What would you do with that?
You would factor it.
You'd factor. What do you mean factor?
The one where you find the common.
You'd find the common one first. What is common to 12 and 48? 12. What is common to x cubed and x? X. So I would take out 12x. Where does that go? To the front. And in here is my answer. X squared minus 4. Now what would you do? Right. X plus 2, x minus 2. Everybody cool? You already know how to do it. It's GCF and then it's difference of squares. Everybody good? What if it was x to the 5th?
Then you would just have 3 x's.
Then it would be x to the 4th, and this would be x squared and x squared, wouldn't it? Good. Okay, everybody can handle that. Excellent. Usually that takes longer. Weird. I don't really know what to make of that. You guys must have a good math teacher. Shut it. All right, next one. What if I gave you this?
They have square root.
Shucks, isn't that the same thing as you just did? What if that was the letter M?
Oh my James.
What would you have?
Just have M squared.
M squared minus 16. Is that a square?
Yeah.
Is that a square? So what would it be?
M plus 16.
M plus 4. M minus 4.
But there's no M. What's M really?
X minus 3.
X minus 3 plus 4. And what's this M? X minus 3 minus 4. What do you do with like terms? Collect them. What is negative 4 plus negative 3 plus 4? X plus 1. What is negative 3 minus 4?
X minus 7.
And now that one's done. Crazy, hey?
It's like the lessons you taught us before work with this.
Oh, stop it! Stop it! You're making me blush. It's almost like I know what I'm doing. Keep my mascara dry. I know I've told you this story. I just recently found out that was what you people were trying to do when you fan your eyes. You know when you see fancy people winning an award, women, but some men wear mascara, they're always fanning their eyes. I thought that they were trying to fan so fast they would dry their tears, which is stupid. That's impossible. I found out recently that it's trying to keep your mascara dry so it doesn't give you raccoon eyes. All right, now, wait. Well, 6 has a 6a. You don't even need to write it down because I believe in you. What if I gave you this? Oh my good gravy. I know. Isn't it just
X squared plus
a squared plus b squared? Right? Because they're not the same, so you have to give them different letters. So isn't it just that?
Where's the C squared?
What's the square root of a? A squared. A, square root of b, a plus b, and then what? What's a? X plus 2. Plus, what's b? X plus 7. Times, what's a? X plus 2. What's b? X plus 7. Right? What is x plus x? No!
2x.
Thank you.
You're welcome.
2x. What is 2 plus 7?
9.
9. What is x minus x? 0x. So do I write it? No. What is 2 minus 7? -5. And now that one's done. All in your head. Does everybody see?
Yes.
It all comes back to square root the first one, square root the second one. Doesn't matter what they are. Sometimes you have to do this substitution thing. Gouda?
Mozzarella.
I'll accept it.
Swiss.
Brie.
Blue.
Nice.
Blue.
Blech. Blue cheese should be named bloof cheese. Because that's what happens when you eat it.
Feta.
Feta is delicious unless you've ever worked in a Greek or Italian restaurant. Because if you've ever worked in a Greek or Italian restaurant at your people's age, you're the lowest person there. Which means you are always the person that has to grate the feta. Which is the most disgusting job in the world. Because feta comes in 20-liter pails. The blocks of feta are about this big, this wide. And you got to take them out of their yucky, stank brine. And it's soaking wet. And then you got to put it on a cutting board, and it drips feta snot all over the place. Then, because it's this big, you got to get a giant knife and cut it into chunks, and it makes a big stinky mess. Then you got to pick it up. Then you got to put it in the cheese grater, and you got to push, grrrr, and it grates. But because it's not hard cheese, it goes everywhere, and the whole grater is covered in feta goo. But because the person who runs the restaurant is too cheap, they make you scrape all the feta out of the machine. And then, because you're the lowest person there, you're also probably the dishwasher. Then you got to go wash that stuff. And you got to do it every day. And you smell like smelly feet. Which is why feta cheese is really feta cheese. Because it smells like feet. Even though it's delicious. And I love it. What?
Did you work in a Greek or Italian?
I worked in both Greek and Italian restaurants.
Is this how you know from experience?
Yes.